Another reason it is difficult to run about assembly instruction is its nature of assembly instruction. In this lecture, I'm going to explain about second reason why it is difficult to understand the assembly instruction. For this, we need to know the nature of and features of each assembly instruction. Important thing is, individual assembly instructions are much simpler than C statement in terms of simplicity and complexity. The main reason is each assembly instruction perform even basic tasks. For example, when you run MV instruction, the copy operation is performed. The destination register hold the result. When you run add assembly instruction, the addition operation is performed between two operands. So nature of each assembly instruction is very simple. It is much more simpler than C statement. So this is another reason to why it is hard to understand the assembly routine. That is, let's assume that you understand the syntax of each individual assembly instruction. But what you have to do as system software engineer is to understand assembly routine consists of multiple assembly instructions. So if you focus on the syntax of instruction, assembly instruction, and it is hard to concentrate on your energy because just the understanding the syntax of assembly instruction is just like to read the grammar book in English for foreigners. So if you first learn about the new language, I know that understanding of the grammar is important. But another important task to learn about the new language is to be exposed to the content with various examples. Take for example, if the foreigners try to learn the Spanish for the first time, they need to know about syntax and grammar of the Spanish language. And next thing they have to do is to read the sentence, and that make them feel interested. But that philosophy should be applied to the situation when you run the assembly instruction. So I'm going to point out that it is important to review the assembly routine consists of assembly instruction. With this activity, it will enhance your understanding of assembly instruction. But if you only focus on the syntax of assembly instruction, I think that it cannot enhance your understanding of assembly instruction, assembly routine. In addition, so it is hard to understand what the assembly routine performs. Here is another example related to what I explained it in the previous slide. So this is the body of the function in Linux kernel. Name of the function is switched to, and let's assume that you are only focusing on the syntax of each instruction. So when running this instruction, the addition operation is performed between first operand and the second operand. It could be the first source register, it could be second source register. The result of this assembly instruction is stored into the X14 register. In this case, X14 register is destination register. But I think if you focus on the syntax of instruction, and it is hard to understand what this routine is trying to perform. So if I look at some vision, object of this assembly routine is to add the offset to the data struct in the task struct. The task struct is one of the data structure in Linux kernel, and in the task struct there is element called thread. So in order to move to the address in each element, addition operation using add instruction should be performed. That is the main reason why this instruction should be performed. And what I explained it so far can be applied to another assembly instruction. So this instruction, as the instruction perform some storing specific data into the memory spaces. So when I interpret for this instruction, so I can say that value in the X1 registers is stored into the address specified in X13 register. And I can say that when running this instruction, the value in the X2 registers is stored into the address where the address is located. Is the value in X13 registers is added to 8. But if you read each assembly instruction in this manner, and it is hard to focus on your energy, because much more important thing is to understand what this assembly routine does. So if I look at this assembly routine from another perspective, and this assembly routine is designed to store some general purpose registers into the specific memory location, and that memory location is specified in here. So this assembly routine is to store this general purpose registers into the element inside task struct.thread. So this is called the operation related to task switching in Linux kernel. So later lecture, every time I am in situation to explain the new assembly instruction, and I'm going to take for example of various assembly routine consist of add assembly instruction, add the assembly instruction, and number of another assembly instruction defined in RISC-V architecture. So in this lecture, I just talk about the second reason why it is hard to understand assembly instruction for beginner. That is the nature and feature of each individual assembly instruction. So you don't have to worry about it. I'm here to help you. If you watch this course, I'm sure that you will have the solid understanding of assembly instruction, because I will provide a lot of practical example assembly routine that is associated with the new assembly instruction you are running. The next lecture, I'm going to explain about the last reason, another reason why it is hard to understand assembly instruction.